All right, hello guys. I just want to give a quick explanation of something called Pascal's triangle real quick, which you looked at yesterday, and then jump to essentially where this ties into is called the binomial theorem or binomial expansion. All right, so Pascal's triangle is a bunch of numbers stacked up like a gigantic triangle, where we start with the 0 row, the first row, the second row, third row. Pretty easy to see that. In the rows we have elements, so 0, 1, 2, and 3, or 0th, first, second, and third. Those elements all line up with, and each row lines up with, different combinations. So 3C0 is actually 1, 3C1 is actually 3 when you calculate, 3C2, and so on, and 3C3, and it actually generates this 0, so lines up with the 0 down here. First term lines up with the 1 here. Third term lines up with the 2 down there. And then 1, or third term, lines up with the 3 down here. And then so I can look at the same thing, which is what you did in class yesterday, was the fourth row, where you got 1, 4, 6, 4, 1. So using the combination formulas. Okay. So hopefully you're with me there. If you have questions, I suppose you can email me or ask a neighbor if something's unclear, or do some more Googling. But that's essentially the long and the short of it. And Pascal's triangle is super helpful because these numbers give me coefficients on something we call binomial expansion, which I'll show on the next page. Back in this fifth row, there's a 1, 5, 10, 10, 5, 1. I don't know which one it is yet, so let's check 5C2 and do this by hand. It should take me to a 10 right there. Okay, so now I'm on the next page. If I want to expand something like x plus 4 to the third power, that's the exact same thing as saying x plus 4 times x plus 4 times x plus 4. And what you have to do is follow distributive property and take x times x times 4, and so on, and get a simple binomial, or trinomial, sorry. So you multiply all that out, and you're going to get an answer. And your answer, luckily for me, I'm smart, is going to be x squared plus 8x plus 16. And then you're going to multiply that by that x plus 4 that's still remaining, and then distribute again, and get a bunch of like terms and combine and all that stuff. It's not a terrible amount of work, but I could make it a lot more troublesome if I change my power from a 3 to something like, if it'll erase here, let's say a 7. And what happens is this binomial ties into the 7th row of Pascal's triangle, followed by a bunch of other stuff. So that other stuff looks like using combinations to help me get my coefficients. And so coefficients, I mean numbers in front of my variables. And then what do I do with these powers? Like you say, Mr. Carter, how did you know that it was going to be x squared plus 8x plus 16? Well, I know that if I'm multiplying two things together, I'm in the second row of Pascal's triangle, so I know that it goes 1, 2, 1, and then I'm applying some power rules to this first term in the binomial, this x, and I was applying some rule to the second term of the binomial, and it helps me figure out these terms, these numbers here and here. And then I can do it again to go to the last final answer. Okay, so we're going to look at this document that I have attached in Canvas. So it's another paper, it's your actual assignment, and it looks a little bit like, if I look at Pascal's triangle, back to the problem. This, one side of it is all I've got on here are the odds, and I don't have all of the odds. I skipped a couple of them. So I'm going to try to run through these examples as quick as possible to save you some time. I do not want you to do every problem on this assignment. I just want you to do the evens only. So we'll look at how do we do examples so you can get through your assignment. So at the beginning it says find each coefficient described, coefficient of x squared in expansion of 2 plus x to the 5th. Expansion of means just blow that thing up, right? So multiply 2 plus x by itself 5 times. Well, there's a lot of work, so we're going to use binomial theorem to kind of help us. Binomial theorem or binomial expansion means I'm dealing with combinations, and I'm dealing with powers on each of these terms. So the first thing I do is realize, okay, I've got a power of 5, which I think of that in terms of my NCR stuff. So NCR that is 5 is my n. So the first coefficient is going to start with a 5 choose, and then at the very beginning we always start with a 0. So 5 choose 0. I like 5 choose 0 because that ends up always being 1. It's like saying I've got 5 objects, pick 0 of them and group them. There's only one way to do it, pick nothing. So my answer is a 1 there. And then I multiply that by, let me make that actually look like multiply, so times, and then I go with my first term, a 2. So that 2 I'm getting from right here. That is going to get raised to that power of 5. So I'll use a different pen here. Power of 5. Then I'm going to multiply that by my next term in the binomial, x. That's going to get raised to the 0 power. That should be a nice 0. Okay. I'm using 5 and 0 add together to make 5, which was my original power. So I'm not going to, I don't want these combined exponents to be anything different than 5 if I add them together. Okay, so then I go plus. And I go with 5 choose, or 5c, 1. And not a plus, sorry, times, so parentheses, 2 raised to the, and I drop the power by 1, so 4. And then I go to my x, and I raise its power from 0 up to a 1. So I still add those two red numbers there to get 5. And I can continue this pattern with going with plus, oops, I want blue there, plus 5 choose 2 times 2 to the third times x squared plus, slide over some more. Well, I don't think we need to go any further, right? Because it's saying what's the coefficient of x squared, an expansion of. So it started with 2 to the 5th, x to the 0, 2 to the 4th, x to the 1. So you can think of this as starting with my 0, my 1, then I'm going over to my 2. So it's wanting to know what's the total coefficient here. Well, I need 2 to the 3rd. This is attached to my x squared term. So 2 to the 3rd we know is 8. And then what is 5c2? Well, 5c2, you can use a calculator for this, guys, once you get your factorials written out, is 5 factorial, my pen will work, over 5 minus 2 is going to be a 3 factorial, and another 2 factorial. Well, that is going to end up being the same thing as 5 times 4 divided by 2, or 10. And you can use a calculator to check that for me, but it should be a 10. So I'm going to have 10 times 8, and that is actually the whole coefficient on x squared. So 10 times 8 is 80, and I'm done. Okay, so that's first example. We're just finding a coefficient on that binomial. You don't need to expand the whole thing, just really far enough to get you where you need to go. Okay, so the next one is saying, well, number 5, coefficient of x cubed y squared, an expansion of x minus 3y to the 5th. Holy crap. So this one's a little bit different. We're going to start with, again, what's our power? Our power is 5, so it's going to be 5c0 to start. And then, if I think about that, where I can speed this up is that's these 5c0, 5c1. These are terms in Pascal's triangle. Well, I don't know which one to use in that, which one it is. Well, what I'm going to do is go, my first term should be x to the 5th. So I've got some NCR thing, I've got some 5 choose whatever, 5 choose 0 at the beginning, and then x to the 5th. Okay, then there's going to be something with a y here, y to the 0, and then it's going to go x to the 4th, y to the 1st, x to the 3rd, y to the 2nd, and bingo, there we go. What that's telling me is I've got 5c0, 5c1, 5c2, 5c2, and I can check that, and it's going to be the 0, 1, or 2 term in path. So that 5c2 is a 10, if I were to do all the factorial work. So 5c2, that's going to be a 10. And one thing I left off is you say, well, Mr. Carter, what about that -3 on the y? Well, that actually gets powered as well, and since it's attached to the y, it has the same power as the y in that spot. So my y has an exponent of 2. I need to take that -3 and apply an exponent of 2 on it as well. So I'm going to end up with 10 times -3 squared. So 10 times 9, or 90. If I were to expand this entire polynomial or binomial, this first, second, third term would be 90x cubed y squared, without having to do a lot of work. It's like a shortcut. Okay. So if I go down to number 7 says second term an expansion of y minus 2x to the 4th. When they're saying second term, they literally mean the actual second term, so I'm not referring to the 5c0 as a 0 term, 5c0. This is my first actual term in that polynomial. So I'm going to skip this first one and go straight to the next one. So it should be something c1, okay, and it's my power here. So 4c1. So I'm trying to give us a shortcut here. 4c1 times, okay, so when I start this problem off, back at the first term, I should have y to the 4th. Okay, and then this second term in binomial will have a power of 0 or nothing. When I go to the next term, so this second term I'm on right now, this is going to have a y cubed in it. Okay, and then my -2x is going to get powered with a 1. Okay, so before choose the 1 always has to go there. So I have to follow power, choose, well, I know I'm choosing 1, and it says second term. That's because it starts with a 0 and then goes to a 1. So if I simplify all that, 4 choose 1 is just a 4, and then y cubed and -2x. But I still need to multiply the coefficients, so I'm going to get 4 times -2, which is -8, y cubed x. Now, technically, some teachers might get a little crazy and say, well, we've got to put that in alphabetical order, so -8x y cubed. Depending on your teacher, that can be different from class to class, but they mean the same thing. So just be aware of that. Okay. So number 9 says the first term in expansion of a plus b to the 5th. So they really want the first term. So we're going to start with our power. 5 choose 0. 5 choose 0. It's always going to be a choose 0 at the beginning. And then times a to the 5th times b to the 0. So I'm taking each term, kind of distributing out my powers, so I put all 5 of them on the a, and I can't put any on the b. Okay. If I simplify that, I actually am just going to get a to the 5th. Okay. Here comes the real work. How do I expand something like 2m minus 1 to the 4th and number 15 down here, y minus x squared to the 3rd? So here we go. Remember, I'm choosing out of a group of 4, so this thing would go 4, choose 0, times, and I take my first term, the 2m, apply my full power of 4 I have, my -1 gets a power of 0. Then I'm going to add my next term. It's going to go 4 choose 1 times 2m, and I drop the power by 1. I'm only going to put 3 of the powers there, times -1 to the 1. Okay, then I'm going to keep going at that same pattern, plus 4 choose 2 times 2m squared times -1 squared. Only a couple more to go. I know this does seem like a lot of work, but it's a lot shorter than doing all the massive, like, distributive property. So 4 choose 3, that goes up, 2m cubed times not cubed, sorry. That's got to drop 1, that's got to go to a 1. -1 cubed, that's the one that gets the cube on it. And then our last term is going to go plus 4 choose 4 times 2m to the 0 times negative 1 to the 4th. Okay. Nice thing is anything with a 0 power on it we can ignore. The 4c4 is nice and easy because this thing becomes just a plain old 1, like in the outsides of Pascal's triangle. 2 to the m to the 0 becomes a plain old 1, and so all I've got to worry about down here is this negative 1 to the 4th. Negative 1 to the 4th is a plain old 1, so I've got 1 times 1 times 1, or just a plain old 1. Okay, that's the easy part. Gets a little trickier from here, so I'm going to go back to the beginning so that I'm going to follow that same idea. 4 choose 0 is just a plain old 1, so that's easy to ignore. But 2m to the 4th, you have to distribute the exponent to each term, so 2 to the 4th is a 16, m to the 4th is m to the 4th, so you would have 1 times 16 m to the 4th. Now, some of these, because there's that negative 1 that's being powered, negative 1 to the 1 is going to be a negative 1. So what that's going to do, it's going to flip all of my signs here. This is going to become negative. So I'm going to get a negative. And 4 choose 1 is just a plain old 4. And I've got to apply that power of 3 to both terms. So 4 times 2 cubed. So 2 cubed. Well, 2 cubed is 8. So I'm going to get 4 times 8, which is 32. And then the m gets the power of 3 on it. And I already took care of the negative 1 by making that a negative. Okay, so the next term, negative 1 squared, I'm going to deal with that. Negative 1 squared is positive 1, so nothing's going to happen there. I can just basically ignore it. 4 choose 2, though, is, I can use my calculator, it's 4 factorial over 2 factorial, 2 factorial, so it would look like this. So it would look like 4 factorial over 2 factorial, 2 factorial. But you actually did that yesterday, and it turns out to be just a plain old 6. So it turns into a plain old 6. And this 2 exponent gets applied to both terms. So 6 times 2 squared, or 6 times 4, which is positive 24 m squared. And then last, my 4 choose 3. That ends up being a 4, if you factorial that out. And then I get 2m just to the first, and negative 1 raised to the third power. So negative 1 times negative 1 times negative 1 is a minus. So that's going to change my sign again. And now I've got 4 times 2 up here. 4 times 2. I guess I should highlight that or laser pointer it. 4 times 2 is 8m. And then my little lonesome plus 1 I wrote earlier, I'm just going to write that right here so I can erase it off of there. Maybe erase it. Let's see if that can go away. There we go. Okay, so our final answer would have looked like this. 16m to the 4th minus 32m cubed plus 24m squared minus 8m plus 1, which that seemed like a lot of work, but it's a heck of a lot better than taking 2m minus 1, multiplying it by itself 4 times, and doing distributive property 4 times. So then we'll do this again for the last one. What happens when I have 2 variables involved? Follow the exact same idea. So I've got to start with my combination stuff. So I've got an exponent of 3 up there. So I'm going to start with 3 choose, or 3c. 3c 0 times, take my first term, that y, and cube it. Second term is a negative x squared to the 0 power. So that's my first term. Very easy to set up. So next term plus 3 choose 1 times y, and I drop the power from a 3 down to a 2, times my negative x squared, and I raise the 0 up to a 1. And then I move on to my next term. I go with plus 3c2 times y to the, gotta drop the power by 1, so it goes down to a 1. The negative x squared goes up to a 2. Okay, and then I move on, and I've got on my last one here, plus 3c3 times y to the 0 times negative x squared to the third power, Okay, so we're dealing with a couple of things. There's negatives again. There's multiple variables. There are powers of a power. So we take it one step at a time. 3 choose 0 is just a plain old 1. So it doesn't matter. That's always how that first term is always going to be a 1 there. And then I've got my 1 cubed, or y cubed, which is just a plain old y cubed. And I've got my negative x squared to the 0 power, this thing, which is just a plain old 1. So that is going to go away. So I just start with a y cubed. Nice and easy. The next part, 3c1, that's just a plain old 3. Okay, and then I've got my y squared, but negative, and then a negative x squared raised to the first, or negative x squared. So this is going to, this negative on the x squared is going to turn my 3 into a minus 3y squared x squared. Okay, so now my next term is dealing with that 3c2. Well, 3c2 turns out to be just the plain old 3. And then my plain old y to the 1 is just a y. And my negative x squared squared. Okay, how do I square this thing? Well, this is a negative x squared times a negative x squared, or a positive x to the 4th. And you can notice you can actually multiply those exponents to speed that up, but I'm going to end up with a positive 3y x to the 4th. Okay. So I've got y cubed minus 3y squared x squared plus 3y x to the 4th. And now we're on to our final and last term, the easy one, because 3c3 is just a plain old 1. Y to the 0 is a plain old 1, so we don't have to deal with any of that. We just have to deal with negative x squared cubed, which is negative x squared times negative x squared times negative x squared. Whew! Negative times negative times negative is a negative. So minus. And then x squared cubed. So x squared raised to the power 3, and multiply these exponents. So it's going to be x to the 6th. Okay. And I end up with this little 4-term polynomial, y cubed minus 3y squared x squared plus 3y x to the 4th minus x to the 6th, which I know that seems like it's a lot of work, but it's really only a couple of steps. It's just memorizing the pattern. Okay, so we looked at that gross binomial formula yesterday. Just try to memorize the pattern. That's my best advice. And so if we're still having trouble, we can talk about that when I come back on Thursday. So your assignment, do the evens. And I think I typed that into Canvas. And that is all. Have a good day.